Okay, I'm going to go through task 14 and 15. This is a summary of some of the stuff we have already covered. I can't remember how many skill sets we've done. I think we've done 4 or 5. So we've got A, B and C represent length. State whether these lengths could be a length, area or volume. So our first one, we've got 1, 2, 3 there. So that means therefore that's a volume. This one we've got 1 and another 1. Therefore that's a length. And this one, if we expand our bracket first, we've got 3AB plus 3AC. So we've got 2 and a 2. That makes an area. The one next to it, so we've got right 2,250, as a part of this prime. So we start with 2,250. I can't even say that number. So that could be 225. I can say that. Times 10. So neither of us are prime. So 10 is 2 times 5. Those are both primes. 225, we could do 5 and 45. 45, we've got 5 and 9. And 9, we've got 3 and 3. Wow. So 2,250, so to write that time, is 2 times 3 to the power of 2 times 5 to the power of 3. What is the smallest number that can be multiplied to make a square number? So don't forget, square numbers, the powers need to be even. So we need another 2 and we need another 5. So if we need another 2 and 5, that means we need to multiply it by 10. Right, next one. Should we do the mug first? So we've got a mug, holds 250 millimeters, correct to the nearest 5 millimeters. We need the lower and upper bounds. So for our upper and lower bounds, we take wherever we're rounding to, we half that, and then we take it away for our lower and add it on for our upper. So for our lower bound, we've got 247.5 milliliters, and upper bound we've got 252.5 milliliters. Let's go do the one underneath it. So we've got 27 to the power of minus 1/3. So we've got that means it is 1 over, because it's a minus, so it'd be 1 over 27 to the power of 1/3. Anything to the power of 1/3 means the cube root of it. So we're going to cube root 27. Cube root of 27 is 3, so this would be 1 over 3. Next one, I'm going to do the one underneath. So we've got state the interior angle of a regular nonagon. A nonagon has 9 sides. We could do this a number of different ways because it just wants the interior angle. We could work out the total interior angles. We could do 180 times 9 take away 2, so 180 times 7, and then divide by 9. Or, quicker way, we could do 360 divided by 9, which is 40. So that's the exterior angle. To get the interior angle, we could just do 180 take away 40, which is 140 to get the interior angle, because it wants just the interior angle. Now this wants me to construct a 45-degree angle. Now I have done this in a previous one. I don't have a compass, so apologies. But first we're going to have to do a perpendicular bisector. So we need to cut our line in half. To do that, you're going to put your compass point at one end, and you're going to stretch that to over halfway, and you're going to draw a nice arc, really nice straight one, just like that. Then we're going to put our compass point on the other end, and we're going to, don't move your compass, we're going to draw another arc. Oh gosh, it's so bad. Then we're going to join those up. See how it crosses here and here? We're going to join those up with a nice straight line, which is really good. I should be an artist, I know. So that, on yours, hopefully, if you've got a compass, makes a 90-degree angle. To make a 45 one, we just need to split that in half. So we're going to put your compass point here, just where you've just intersected your line. And we're going to draw a nice arc. So it's just cut this line here. You're going to cut this line here. So put your compass point back up here and draw a nice arc. Compass point here, draw another little arc. And hopefully, when you join that arc, that cross up to the middle, it cuts it, and that is 45 degrees. Okay. Right, task 18. So again, we are summarising all the stuff we've done so far. So if we're converting 7 11ths to a fraction, that just means we're going to do how many times does 11 go into 7? And 7 has got an infinite amount of zeros after it. So how many times does 11 go into 7? It doesn't. So we carry all that 7, decimal moves straight up. How many times does 11 go into 7? It goes in 6 times, because 11 sixes are 66 with a remainder of 4. How many times does 11 go into 40? Well, it would go in 3 times, because 33, remainder of 6. How many, not 6, bloody hell, miss. 33, what can I write? 33, so a remainder of 7. Gosh. So how many times does 11 go into 70? It would be 6. I think that's where I would get my 6 from in my head. So that'd be 66, remainder of 4. How many times does 11 go into 40, etc.? 3. You can see a pattern there, so it's going to 0.63 recurring. Gosh. Right, a square has a diagonal of 15 centimetres. Find the length of the side of the square. I'm just going to sketch this. So we've got this diagonal length is 15 centimetres. We've got to calculate the length of the square. Now this is x. This is also going to be x. So we've got a right angle in there. We've got one side, that's the hypotenuse, and we need the other two sides. However, they're going to be the same. So we've got a right angle triangle and we're working with sides, therefore we should understand that that means we've got Pythagoras. So Pythagoras would be, I would do x squared, I would add another x squared, that would give me 15 squared. So I've got 2 lots of x squareds on this side to give me 15 squared. So 15 squared, let me just rewrite that there instead. 15 squared, hopefully we work out as 225. I just want x. So if I divide it by 2 first, I got x squared is going to be 112.5. Then if I take the square root of it, I get that length. So the square root of 112.5 is 10.6. So that is Pythagoras. A little bit tricky though. So first of all, we basically squared our 15, we halved it, and then square rooted it, because we've got 2 of them. Right, next one. We've got a mug holds 250 millilitres, correct unit is 5 millilitres. Upper and lower bound, so we take where we're rounding to. We half it, so half of 5 is 2.5 millilitres. We're going to subtract it for our lower bound, so 247.5 millilitres. I'm going to add it on for upper, so 252.5 millilitres. The one next to it, standard form. When we're dividing in standard form, we divide our numbers. So we're going to do 7.2 divided by 2, which is 3.6. Then we're going to divide our 10, so our 10 to the power of 5 divided by 10 to the power of 4. When we're dividing our powers, we subtract them. So minus 5 minus another 4 gives us minus 9. So our answer is 3.6 times 10 to the power of minus 9. Next one, we've got 36 to the power of minus 1/2. So anything to the power of a minus means we flip it. So this is going to be 1 over 36 to the power of 1/2. Anything to the power of half is a square root, so it's going to be 1 over the square root of 36. Hopefully we know the square root of 36 is 6. I'm going to leave my construction till last, because you know I'm amazing at it. State the exterior angle of a regular decagon. So a decagon is a 10-sided shape. Exterior angle, easy, 360, just divided by the number of sides. So that is going to be 36. And the moment of truth, I'm going to construct a 30-degree angle. Right. Don't have a compass. So first of all, to construct a 30-degree angle, you're going to want to make a 60-degree angle by just making it an equilateral triangle, and then we're going to cut it in half. So to make a 60-degree angle, you're going to put your compass point at the one end, and you're going to stretch it all the way out to the other, and then you're going to make a nice arc. You're going to do the same from the other end. I'm going to make a nice arc. Now you've made an equilateral triangle if you were to join all sides. If you just join this up, that's 60 degrees in there. So to get 30 degrees, we're just going to half that. Here's my pen. So to half an angle, we're going to put our compass pointer up in the corner. We're going to draw an arc. Then it's cut your line here. Put your compass point there. Make a little arc. Put your compass point where it cut the other line. Make a little arc. And join that up. Not too bad if I don't say so myself. So that should have been